My name is Driss Berada from UWS College, and welcome back to this series of videos. In this video, I will explain how to calculate a moment about a point. The content of this video is moment of a force about a point, and I will discuss the scalar formulation into D. Secondly, I will talk about Varigno's theorem. Third, moment of a resultant, and finally the moment of a couple. What is a moment? A moment is a tendency to rotate a body about a point, A or O. So we can write M about this here. Suppose we have a bar like this, and I've got a point O here, and this bar, on this bar we apply a force F. So in physics we define the moment about O, and we write it M subscribe O as F times D. And here is very important to notice that, to remember that this D here is the perpendicular distance from F, from the line of action of F to the point O. Perpendicular distance. So M is F in scalar formulation is F times D. D, I also again I emphasize on that D is the perpendicular distance to the point where I want to calculate my moment. Of course, the unit of the moment is F, which is in newtons, times D in meter. Now I will give three simple examples on how to calculate a moment. Let's take this first example. I've got, for example, a bar like this. Got my point O here, and the force F is perpendicular to the bar, and for example F equals 100 newtons. So if I am asked to calculate the moment about O of this force F, simply what I have to do is to take 100 and times it by the distance. Suppose the distance is 2 meters times 2. Finally, MO is 200 newtons meters. Simple, isn't it? Now, I'll change the configuration, and suppose now I want to calculate a moment of a force, and my system here is something like this. Got, for example, here 4 meters, and I apply a force of 50 newtons. Here's some, for example, some values, some figures that we need. 0.5 meters. Now, the line of how to calculate the moment now about O of this force F, I have to draw the line of action of this force, and this force finding is like, if it's applied here, at a distance of 0.5. So therefore, M equals 50 newtons times the perpendicular distance. The perpendicular distance is here, from here to the point. So the perpendicular distance is here. So times 0.5, which is 25 newtons meter. So again, M, the moment is the force times the perpendicular distance from the line of action. Now, another case when we have to apply the rules of moment. Suppose I have, my system is like this. Sorry about the graph, because I don't use any ruler or. Suppose I've got my system like this, my body is like that, in which I have 2 meters here, from here to here 1 meter, and here from here to here 5 meters, and I am asked to calculate the moment of a force of 10. Suppose the force is applied here, my F is 10 kilonewtons. So the force is applied at this point. Now the moment about O is F times the perpendicular distance to the point. So what is the perpendicular distance? I have to draw my line of action. So the force is like it's applied here. At which distance? The perpendicular distance here now is 5 minus 1. So the distance is here now, the distance, and it's 5 minus 1 times, of course, the 10 kilonewtons, which is 40 kilonewtons by meters. I showed you here three examples on how to calculate the moment in different configurations, 3 configurations, by using the rule of calculation of the moment in 2D by using the scalar formulation. So we have seen the case where the force applied to a body, this force is applied perpendicularly to the body. Now, in the case when the force is not applied at a right angle, there are 3 possibilities to solve the problem. The first one is to work with the arm D, and this arm D should be perpendicular to the rod. Also, we can use a second method, which is method of components. We will call them dx and dy. And the third method is where we set in the x and y axis perpendicular to the rod. So 3 methods to solve the problem. 3 methods to solve the problem. Or to find how to calculate the moment in the case when the force is applied but not perpendicular to the axis. So let's see the first method. Here we have an example in which we have a force F applied to this rod, but not applied at 90 degrees, but applied at this angle 45 degrees. So first thing, if you want to calculate the method using the arm D, we have to calculate this arm D. What we have to do is to find the perpendicular distance to the point O from the line of application of F. So we have our line of application here, and we have to find the perpendicular distance. If I just try to... So this perpendicular distance will be, in fact, here, somewhere here. This perpendicular distance, we call it the arm D, is now here. How to find it? We launch we follow the line of action of the force, and we draw the perpendicular to the point where we want to calculate the moment. So the moment now at the point about O is D times the force. Now, what's D? This distance. I have the angle 75, and D is opposite to 75, so it's, and this distance here we have it, it's 3 meters, so it's 3 sine 75 degrees. Finally, the moment M for both O is F, which is 5 times 3 times sine 75 degrees. And I've got the, here as I did the calculation, is 14.5 kilonewtons per meter. Of course, now I haven't talked about the direction of the moment, because the moment in fact is a vector, and a vector has a magnitude and direction. So the magnitude of the moment is 14.5 and the tendency to turn this rod is clockwise. The rod, if we apply a force, it will turn clockwise. This is how we do when we want to calculate a moment when the force is not applied perpendicularly to the body. We use the arm D. We have to find arm D. I recall how to find the arm D. You have to draw the line of action of the force. From this line of action, you find the perpendicular line to the point where you want to calculate your moment, and you apply the definition of the moment, which is force times distance. Now I will explain how to use method 2, method of components. What about now? This method is a little bit tedious. We have to to choose a system of axes x and y, we orient them like this, positively. Oh. Now, the method consists of finding the component of the force F along x and along y, and to multiply these components by the component of the force. So it will be, for example, for a force, it will be Fx, that means the component of the force along x times dy, the distance from the y-axis, plus the force along the component of this force along y times the distance to the x-axis. Now, to start the calculation, I have to place my system of axes x and y at the point O. I place here O. So my x is here, my axis x here, and the y axis is that point. Okay. My point O is here. My road is 3 meters. Okay. Now, dy is this distance, in fact, along y. From O is dy is here. All right, and dx is along x, is this, in fact, this distance from here to here. Okay. Now I've got my dx and dy. Now I have to find my fx and fy. Fx is the component of the force along x. Okay. The component of the force along x, the x-axis which is parallel to this one, is F equal 5 times the cosine of 45 degrees. And the vertical component is 5 sine 45. Now I write everything here. I start first by calculating dy. So dy is this distance. The angle here is 30 degrees. That means this dy equals 3 sine 30. 3 sine 30. My dx is 3, and this is the distance dx, which is here, which corresponds to the cosine of 30. D, which is 3 cosine 30. Fx is the component along the horizontal axis, which is here, is 5 cosine 45. 5 cosine 45 degrees. Now Fy, which is the component of the force F along y, the vertical axis, which is 5 sine 45. Now all what I have to do is to write now, to add everything. Fx, which is 5 cosine 45, times dy, which is 3 sine 30, plus Fy, which is 5 sine 45, times dx. Dx is 3 cosine 30. And just double check. 5 cosine 45, 3 sine 30, plus 5 sine 45, 3 cos 30. The answer now, if you put this into your calculator, you will find 14.5 kilonewtons, the same value that we found previously by using the method, the arc method. So kilonewtons per times meter. Okay, this is the method of another method to calculate the moment about O is the method of variance. We call it variance theorem. It's number 2 in this video. Variance theorem. Variance is the name of the guy who found this theorem. This method, the principle of calculation of the moment is the following. The moment of a force about a point is equal to the sum of the moment of its components about that point. So the moment, we can write it, the moment of a force about any point is equal to the sum of the moments of its components about this point. Variance theorem. And to illustrate this, I will choose an example, simple one. Okay, the moment of a force about any point is equal to the sum of the moments of its components about this point. So we have to find the components of this force about the components of the force and try to find the moment about the point of. Let's look at this example. We have a force of 45 400 newtons applied at an angle of 30 degree here, 30 degrees, and this distance here is 0.4 meters, and from here to here is 0.2 meters, and we want to calculate the moment of this force about this point O. So the moment about O, according to Varinius, is the 400, so the line of action of this, sorry, not the line of action, but the component of this force F along this axis X and this one Y. Okay, just this distance here, this component here, Fx is 500 sine 30, and along Y, which is this distance here, this component, which is Fy, is, it's not 500, it's 400 sine 30, and this one is Fy equals 400 cosine 30. Now, this is my Fx, the component of the force along X, and here the component of the force along Y. So, according to Varinius, what I have to do is to take the component of the force along Y here, which is 400 cosine 30. 400 cosine 30 times the distance, the line of action of this force, in fact, of this component is here, and this distance from the point O, I find my 0.4 here. So times 0.4 plus the component along X, which is Fx, 400 sine 30 times the distance that separates the force Fx to O, which is this distance, 0.2. Now, doing this, I got calculation 9.8, it is 98.6 newtons meter, and as you can see, the force will turn clockwise. So 95.6 clockwise. I'll choose another example here. Okay, how about now? Another example of Varinius theorem. Suppose that I have to calculate a moment of this system. I've got a rod like this, with another rod here. This one is at 45 degrees. Okay, I've got system of forces. I've got one force here, 600 newtons, and here I've got 300 newtons applied, and vertically another force of 500 newtons. I'll put the distance here. This distance here from here to here is 2.5 meters. From here to here, 1 meter, and here 2 meters. So what I am trying to calculate now is the moment of these 1, 2, 3 forces about O. So the rule is, when you, or the principle of the moment of a force about a point is equals to the sum of the moment of the forces about this point. I repeat, principle of moments. A moment of a force about a point is equal to the sum of the moments of the forces about this point. So that means I have to calculate the moment of this force about O plus the moment of this force about O plus the moment of the 300 newtons about O. So if I choose my orientation of the moment as clockwise, it's arbitrary, I can choose any direction. I can start with this one, for the first one. For the first one it will be force times distance. Force is 600 newtons times the distance from the point O, which is 1 meter, plus this force, its line of action is here, okay, and the distance that separates this force of 500 newtons is 1 meter plus 2 meters plus this distance here, d. So, but you have to notice that because I have chosen the positive moment as clockwise, these 500 newtons will make the system turn into the other side, anti-clockwise. So I have to take this into consideration for my calculation, otherwise I will get something. So now we have to add the moment of this force, 500 newtons, which is force times distance, and the distance that separates the line of action to the point O is 1 meter plus 2 plus this distance d. And this distance d is 2.5 cosine d equals 2.5 meters cosine 45. 2.5 cosine 45. But there's a problem here. It's not a problem. I have to attract your attention I put plus in a way that we have to add moments, but this moment of this force is making the system turning anti-clockwise, counterclockwise. So if I have choose my positive moment as clockwise, this force will make the system turning anti-clockwise. Therefore, I have to put here minus. This is the moment of the first force, the moment of the second force, and now the moment of this third force, line of action. Okay, and here this distance d dash, I find it here, which is 2.5 sine 45. 2.5 sine 45 degrees. And is making the system turning clockwise, therefore I have to put plus 300 newtons times 2.5 sine 45. You put this into your calculations, into your calculator, and you will find okay, we can do it. It's I did this calculation. It's finally, you can verify it. It's 1, 2, 5, 4 newtons meter, and that with this you will find minus, and this minus means simply it's anti-clockwise because I have chosen the positive sense, rotating clockwise. The minus, that means this moment is making the system turning anti-clockwise. So we have seen here how to calculate the moment of three forces about an axis and how to find the resultant moment. The last part of this video, I will talk about a moment of a couple. Okay. A couple is a system of two forces acting in opposite direction. Simple stuff. We have two forces but equals in magnitude. We have FF separated by a distance d. In this case, we define the moment of a couple. M is F times d, as we have seen before. I'll give an example and I will conclude with this video. Suppose we have to calculate not one couple of moments, but we have this case in which three couples are acting on a bar like this. Suppose we have a bar here in which we have one force here of 300 newtons, another one here acting 400 newtons, this one acting in the opposite direction, another couple of moments here 200 newtons, 200 newtons separated by a distance 0.2 meter. Here we are at the distance 3 meters, for example, and from here to here we have 2 meters, and the force of 300 newtons is applied. I'll just put them in the red. So we have one force here, another force here, another force, drawing all. Okay, and my system is this bar. So, like forces, the couples, if we want to calculate the resultant couple of all these forces, we have just to add them, but we have to choose before doing that and sense of orientation. For example, if I choose this one clockwise, it's arbitrary. You can choose any direction that you want, but you have to choose one. This. So all the moment the couples turning clockwise have to be taken as positive. So let's start. We have the moment resultant of these three couples. I've got this first couple of 300, second couple 400, and the third couple is 200. So the positive moment just will be something active, for example. I have two forces like this, F equals in magnitude. This is clockwise. In this configuration, if I have this, it means I am anti-clockwise, counterclockwise. So I start with the 300. 300 is, according to this configuration, is a positive, and its moment will be the force, which is 300, times the distance that separates the two forces, which is 5. Now I'll move to this one. This one is following this configuration, is positive as well, clockwise, which is force times distance, 200 times the distance that separates the two forces, which is 0.2, and the last one, which is 400, couple of 400, but this is anti-clockwise, opposite. I have to put minus 400 times the distance that separates the two forces, which is 2. So the resultant moment of these three couple of forces is finally 740. So the answer is 740 newtons meter. Positive, which means that is clockwise. So on this video I have shown how to calculate a moment of a force by 3 methods. Also I have shown how to calculate the moment of of a force by using Varigno's theorem, how to calculate the moment of a resultant force, and finally the moment of a couple by taking an example of 3 couples. I would like to thank you for your attention, and I hope to see you in the next video. Thank you.